Hello everybody, welcome to lesson 5. We're going to be learning about geometry. Alright, let's go through these statements, and these statements are going to be very important to know for the questions that we do later. The sum of the degrees in a triangle is always 180. In the diagram below, x and y always add up to 180 because it's a straight line. What equation relates to the lengths of three sides in a right triangle? So if we have a right triangle here with sides A, B, and C, we know A squared plus B squared equals C squared. An isosceles triangle is where two of the sides are equal and two of the angles opposite of those sides are equal. For instance, if we have this triangle here and this side is equal to this side, this angle is equal to this angle. Which of the following three statements are true? So this is about similar triangles. They have proportional lengths, that's true. They have equal lengths, that is not always true. And they have two angles that are equal, that's true. So if we have this triangle here, and we have this triangle here, and we know that this angle is A and this angle is B, we know that this angle and this angle are equal. Similar triangles always have two equal angles because that means that the third angle has to be the same as the other third angle. In a right triangle, the sine of the angle is the side opposite of that angle divided by the hypotenuse. In a right triangle, the cosine of an angle is the side adjacent divided by the hypotenuse. The tangent is opposite over adjacent. The area of a circle, pi r squared. The circumference of a circle is 2 pi r, where r is the radius in both of those cases. The volume of a cylinder is pi r squared h. R is the radius and h is the height. The cone is just 1/3 of the cylinder. The sphere is 4/3 pi r cubed, where r is the radius. The volume of a cube is the side cubed, and a rectangular prism is length times width times height. A equals s squared. The equation above relates the area of a square to the side length of the square. How many times greater is the area of a square with side length 2s than a square with side length s? So here we simply plug in 2s into both equations. So we have a equals s squared, or we plug in 2s for one and s for the other. And we versus area equals 2s squared. Using some exponent rules, we could distribute the 2 within to both of those terms. So the first one is area equals s squared, and the area with side length 2s is area equals 4s squared. So now we look at it. How many times bigger is 4s squared than just s squared? Well, that's 4 times bigger. So its area is 4 times as great. All right, let's do some problems. So we want to find angle x. Well, if we find this angle, we know, let's label that y, we know x plus y equals 180. And then we could solve for x. So, and we also know that this, and y add up to 180 because that's the angles of a triangle. So 50 plus 60 is 110 plus y equals 180. That means y is 70. And if y is 70 and x plus y equals 180, then x equals 110. All right, triangle ABC above is isosceles, where sides AB and AC are equal. So I'm gonna mark those with ticks. What is the measure of angle x? Well, if we know that these sides are equal in an isosceles triangle, we know that the angles opposite of those sides are equal. So the angle opposite of this side is this angle, and the angle opposite this side is this angle. And since they're equal, it has to be 80. And since the sum of the degrees in the triangle are equal to 180, we know that the x and the two 80s add up to 180. So 160 plus x equals 180. That means x equals 20. What is the length of side x? So here we have similar triangles, and there's always a ratio between the side lengths of two similar triangles. How do we know that they're similar triangles? Because two of the angles from this triangle are equal to two of the angles in this triangle. So the ratio of sides is 1 to 2. So if we multiply the side length of the shorter triangle times 2, we're going to get the larger triangle. Shorter times 2 equals larger. So that means 8 times 2 equals x. So x is 16. What is the area and what is x? Well, we know that since we have this little tick mark here, the square, we know that it's a right triangle. So a squared, one of the legs, plus b squared, the other leg, equals c squared, the hypotenuse. So 5 squared is 25, plus 12 squared is 144, equals c squared. This is going to be 169 equals c squared. If we take the square root of that, c equals 13. Or c in this case is the hypotenuse, which is x. So x is 13. And what's the area? Area is just of a triangle is length times width divided by 2. Or base times height divided by 2. In this case, the base is 12. And the height is 5. Divided by 2 is 60 divided by 2, which is 30. What is x if the perimeter is 70? So we know that in a rectangle, we have the bottom base, x plus 5, is equal to the top base, x plus 5, and the left side, x, is equal to the right side, x. So if the perimeter is 70, we know that the sum of all four of these sides is going to be 70. So we have x plus 5 plus x. That's a little x plus 5 plus x plus 5. Because the sum of those four will be equal to 70. If we combine like terms, we get 4x plus 10 equals 70. 4x equals 60, x equals 15. If the radius is 3, we want to find the diameter, circumference, and area. So the diameter, this is the radius, a line from the center of the circle to the edge. The diameter is just the full from the rightmost edge to the leftmost edge, which is double the radius. So if both radiuses are 3, the diameter is 6. Circumference is 2 pi r. Circumference equals 2 pi times the radius, which is 3. So the circumference is 6 pi. The area is equal to pi r squared, which is equal to area equals pi times 3 squared, which is equal to 9 pi. Now let's look at some trig. The sine of x. Well, we know that sine is opposite over hypotenuse. Well, we have the opposite is 6, and the hypotenuse is, well, we don't know that. How do we find that? We use Pythagorean's theorem. A squared plus b squared equals c squared. So a squared, which is 6 squared, is 36, plus b squared, 64, equals c squared. 100 equals c squared, c equals 10. So we know the hypotenuse here is 10. So since sine is opposite over hypotenuse, we have opposite 6 over hypotenuse 10. Cosine is adjacent 8 over hypotenuse, and tangent is opposite over adjacent 8, 6 over 8. Now an important thing to know, let's say I were to label this y. We know that the sine of y equals 8 over 10, and the cosine of y equals 6 over 10. An important thing to know is that these two are equal and these two are equal. That's the theorem here is that the sine of an angle, x, equals cosine of 90 minus x. Now, how do we know that 90 minus x is y? Because since this angle is 90, we know that 90 plus x plus y equals 180. So x plus y equals 90. That means y equals 90 minus x. That's why I was able to make this substitution here. A lot of times the SAT will simply ask, the sine of an angle is 0.4. What is the cosine of 90 minus that angle? And it's good to know this theorem. A cylinder has radius 4 and volume 32 pi. What is its height? So we know that the volume of a cylinder equals pi r squared h. So 32 pi equals pi r squared, which is 4 squared, is 16 times h. If we divide by 16 pi, we get h equals 2. A cone has radius 4 and volume 32 pi. What is the cone's height? So volume equals 1/3 pi r squared h for a cone. 32 pi equals 1/3 of pi times r squared. R is 4, so r squared is 16 times h. I'm going to divide by 16 pi first, just to make it simpler. So we have 2 equals 1/3 h. That means h equals 6. A sphere has radius 4. What is its volume? Well, we know that the volume of a sphere is 4/3 pi r cubed. So we have volume equals 4/3 pi times 4 cubed, which is 64. A cube has side length 5. We want to find its surface area and its volume. So we know that the form of volume is just side cubed, so that's 5 cubed, which is 125. The surface area, well, I'm going to draw a little cube here. We could see 3 sides here, and if each side has length 5, then the surface area of just one of the sides is 25. And we know that there are 6 sides on a cube. So if there's 6 sides and each side has surface area 25, that means there's 6 times 25 total surface area, which is 150. A rectangular prism has length, width, and height 3, 4, and 5 respectively. What is the volume? We know that volume equals length, width, height. So volume equals 3 times 4 times 5, which is volume equals 3 times 20, which is 60. All right, a sphere with radius 3r contains how many times the volume of a sphere with radius r? So note that the volume of a sphere is 4/3 pi r cubed. Now, we're going to plug in r, well, we already did, that's this, and 3r. Volume equals 4/3 pi times 3r cubed. Using our exponent rules, that's equal to volume equals 4/3 pi times 27 r cubed. Now we compare these. How many times bigger is 4/3 pi times 27 r cubed versus 4/3 pi 1 r cubed? Well, that's 27 times bigger. A cylinder has radius r and height h. How many times greater is the volume of a cylinder with radius 2r and height h over 2? So we know that the volume of a cylinder equals 4/3, not 4/3, that's the start of a sphere, equals pi r squared times height. So one of them has a radius r and height h. That's just this. Another one has radius 2r and height h over 2. So if we simplify this, we have volume equals, so the 2r all squared is going to be 4r squared, and the height over 2 is going to stay like that. But the 4 and the 2 could cancel out to just 1, 2. So the volume here is going to be 2 pi r squared. Now we compare. How many times bigger is 2 pi r squared than pi r squared? 2 pi r squared h than just pi r squared h? Well, that's 2 times bigger. A cone has radius 1,600 and height 250. How many times greater is the volume of a cone with radius 3,200 and height 1,000? So let's write the formula. Volume equals 1/3 pi r squared h. Now, I don't want to plug in 1,600 and 250, get a super large value, and then divide by the 3,200 and 1,000. We could approach this in a more logical way. We know that the radius is 2 times as large because it's 3,200 versus 1,600, and the height is 4 times as large. So we could compare this 1/3 pi r squared h to this. Volume equals 1/3 pi. We know the radius is 2 times as large, and the height is 4 times as large. Volume equals 1/3 pi. The 2r all squared is going to become 4r squared, and then times the 4h, we're going to have a scale factor of 16. So it's going to be 1/3 pi times 16 r squared h. So now we have to compare. How much bigger is 1/3 pi times 16 r squared h versus 1/3 pi r squared h? Well, that's 16 times bigger. A circle with radius r contains how many times the area as a circle with radius r over 2? So let's write the equation down. Volume equals pi r squared. And our other equation with r over 2 is going to be volume equals pi times r over 2 squared. Using our exponent rules, that's going to be equal to volume equals pi times r squared over 4. Now, it's a little tricky to directly compare these two, so I'm going to use a factoring tool. I'm going to factor out a 1/4 from the blue equation. So our top right equation can stay the same, volume equals pi r squared, but our bottom equation, I'm going to say that's volume equals 1/4 of pi r squared. That's the same thing as this, but with the 1/4 in front, so it's easier to visualize. So now we have to see how many times as big is the red equation compared to the blue equation. Well, if we multiply the blue equation by 4, we get the red equation, so it's 4 times bigger. All right, that's it. Hope you